Hi, everyone. Welcome back to AI Zen with Andrew and Jen. Great to be here on IBM Expert TV. Today, we're going to do our Think conference review. We've got a couple things we'd like to hit for you. First, why IBM is doubling down on AI. Secondly, what AI we're excited about coming from IBM. And third, a little bit about Watson moments. Jen, you want to start us off?
Yeah, I'm going to put on my Andrew glasses for you.
Oh, I love it.
Now we match. Yeah, starting us off. So Think was different again this year, but at least we had it. So that's exciting. It was online and we had a lot of people join. So that was really fun. And it's always fun to like help all the teams get ready for Think because, you know, and I'm sure on your side too, on the business side, you're always talking to customers like, do you want to come showcase something? Do you want to show something off? So there's a lot of excitement going into it. But like a lot of the messaging this year was about the AI story at IBM. A lot because we've seen so much growth. I think our CEO, Arvind Krishna, said like things are going 5 times faster than we thought they would a couple of years ago. So a lot of what's happening right now is both trying to keep up with the things that our customers are needing, a lot because of what happened with COVID, needing to go more into the cloud, make it easier for people to do their work at home, as well as like all this new data coming in to keep people safe. We did a bunch of new Watson work when COVID first hit, and we deployed this huge new database and map and this great, it was like the most detailed way you could view down to the county level how COVID was hitting your area. So that was really exciting. But we also are looking at it, from a bigger picture standpoint, right? And I didn't realize we were going to have these speakers, and I was really excited to see them. We had people from the CBIN project who are out there using AI to like clean up the garbage in the oceans. We've got the Air Protein project with NASA technology that's growing meat out of thin air. We've got the Center for Humane Technology, which is talking about using tech for good. And like that stuff really kicked the conference off. So IBM isn't just doubling down on like any old AI. I feel like we're really doubling down on like a certain perspective in AI. And I feel like we've been like developing that narrative for over 70 years now. But now like it's starting, as things are getting like more into the hands of people like you and me, it's going out into the world and we're hearing more about like what we think and believe about it. Do you have those conversations with customers?
Yeah, and it's interesting. We've been at it for a few years, but it still feels like we're still in the infancy, right? To bring a concrete example from the COVID, for solving for COVID, a lot of companies wanted to build chatbots when COVID came out. People were calling about all sorts of things, and there was one project I was working with, and they said, "Hey, we have 30,000 employees working from home for the first time, and we need to get them instructions on how to connect to the network and that sort of stuff." Right? And we said, "Hey, no problem. We can slap some AI on that for you. No problem at all." So he said, "Well, how do you get people connected to the network?" And they're, "Oh, well, we hadn't actually written it down."
So I have the data first, right?
So that's a reason we're still in the infancy. No matter where you go, you think you have a great problem for AI, and you probably do. But yeah, you need that data, or you need the business process first. You need to know what you're going to do in order to put an AI solution in place.
Yeah, it is. It feels like baby steps. Even though like you and I have been doing this for years, we know. Like I think maybe you and I know more than anyone else. Like this stuff is the labeling of things. Mostly that's where we are with it. Which brings up another thing that I've been investigating a lot lately. That I'm not fully going to get into, but calling it into the point, like I've been hearing a lot of crazy shit online about how people are afraid of AI and how they think that there's still this giant fear and doomsday perspective on it out there that I think hopefully we can debunk a bit.
Absolutely, and that was why it was exciting to see the trustworthy AI, message. Because what I think of AI is sort of scaling what you already do, right?
Yeah.
And if you were, but I think you beforehand, people could kind of hide behind, well, this is how we do things, right? They had a process, and you didn't like the outcome. Well, tough luck, you didn't like the outcome. So it's not like we had transparency before. But now that we're now that we're really scaling, now that we're really scaling these solutions, and we're trying to take, from a small group of experts to apply it across the whole, corporation, people are rightfully saying, hey, wait, how does this thing work? And if I don't like the outcome, well, why did it happen? How can I dispute it? And it's forcing some real intentional thinking about how the entire thing works.
Yeah, like I feel like that trust just almost is like a synonym for explainability. Like obviously we've got like IBM has its AI ethics site up, and our whole trust center that I think we've talked about on other shows before. So like our ethos is there, but now it's about like, okay, but what does that actually look like in a product? Like, why would I trust any AI in a product? And it's explainability. It's like, hey, I'm telling you this, and I used machine learning to come to this discovery. I use this data. Here's some metadata about this data so you understand the quality of it, or the source, or you can figure out if you trust it or not. And then like, here's unpacking, like, here are the things that I found using these kinds of models, and this is what this model is best for. So like, so much of my work is about helping teams come up with like, yes, ways to explain that to customers, but also not drive them crazy with like volumes and volumes of explainability that we could provide. Like we want it, and we also don't want it overwhelmingly so.
Yeah.
Yeah.
And I heard another story coming out of Think about just how deeply you have to think for the trustworthy process and for the data that you're using. So like by now, I think people are familiar that you need a lot of data, you need good data, you need clean data, et cetera, et cetera. And I think there's a surface understanding of bias in the sense that, well, hopefully you're hitting the different groups, whether by gender, by race, by age, whatever, what have you. But this example came out of the medical group and or medical field, and the idea was something along the lines of, there are some groups that are able to come into the doctor's office like all the time, like for any sort of minor little thing, and they're going to come 5 or 6 times, and you'll have lots of data from those cases because they keep coming, right? And you may have underrepresented groups that it's harder to get to the doctor, it gets more serious. Their conditions are getting undertreated, underdiagnosed, and you may say, "Hey, I've got all these data points," but you've got completely different scenarios. So even if you had the rows balanced by gender, demographic, what have you, there's still an inherent bias that you have to be aware of. So it's really, you really have to think hard about this.
Yeah, because sometimes you need bias. Sometimes you need to like be specific about who you're looking at. But the general statement in the world is like everybody all the time, as much as possible, equally. And that is like you're saying, like there are like challenges to doing that have nothing to do with the data in the machine to begin with. A lot of other issues that are coming up lately around inequality and accessibility and da 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 da. But to get back to like your original question, like why is IBM doubling down on AI? I thought it would be really fun if we did like a quick little like trip through history of like, okay, you're like, yes, IBM's doubling down on AI, but that ain't news to like any of us who work here. Like why is IBM, how is it involved in like the AI story to begin with?
You've got the vintage shirt. Give us the vintage story.
I do have the vintage shirt. Yeah, so I kind of think of it as like two big chapters. But let me set you up before we get into this, like you need 3 things to build AI. You need the data, which we've been talking about, lots and lots of data. You need fast computers that can analyze all of that data without taking days or weeks or months. And then you need some sort of natural interface to translate those insights into something that we humans can understand, not just ones and zeros. So, okay, you have that in your head. data, fast computers, natural interface. So IBM has been working in this space since the 50s on turning what I would say, calling Alan Turing's, hypothesis that we could build a machine that is capable of doing the same things that the human mind does in terms of like communication and consciousness. So something that can perceive what's around it, compare that to its old knowledge and make a decision about something, or have an insight about something. So we've been building POCs about like this Alan Turing perspective since the 50s. The first one was the perceptron, which was built on an IBM 704, which is a very old, big, like boxy computer by this guy, Frank Rosenblatt from Cornell Aeronautical Laboratory. And that's actually, one of the first, it is the first case of image recognition. He's just going through and like, kind of like making the first neural network. And then we've got Samuel Checker's playing program, also built on an IBM, but a 701 electronic data processing machine. And Samuel coined the term machine learning. The Checkers playing program was kind of the first example of how a machine could learn by playing itself and getting better and better. Then in 1999, we had Deep Blue. So we're building a computer that's not just playing checkers. Now we're playing chess. It's making, it beat the world champion. And then in 2011, we have Watson Jeopardy, which took it from chess into Q&A with humans and responding back and forth and beating the champion there. And then since then, I feel like all of those were like, hey, we think this can work. Let's show everybody. Hey, we've got like a new milestone. Let's show everybody. After Watson Jeopardy, I think IBM, because it's been around for so long and because we've got so many people willing to like jump in and contribute, the idea was very much a shotgun approach in my mind. Like, cool, we did Jeopardy. You got this amazing new technology. Everybody go figure out like how to turn that into something people want to buy. And we had like just this like explosion of ways you could use AI. And that became, I think, turning POC, proof of concept, into actual tooling. So like in 2015, we had Watson Conversation, Watson Discovery, Watson Knowledge Studio, a bunch of others like starting to like take that language technology and that data processing technology and turn it into stuff that like people could use. And then it's all like parsing down. It's all now, it's like Cloud Packer Data, Watson Studio, and Watson AI Ops. So like how to get your data, how to make shit with your data, and then how to make sure that that shit is performing accurately over time, which I think is really exciting. It's taken us so long and so many people to figure that out. So that's kind of like the line through time. Like we're not doubling down. We're actually like, now we're just like through some AI winter blockers. Like everybody's getting their data up and running. We've got some faster computers now. We've got some tools in place. So you're seeing it like start to progress forward, I think, more than this like, oh, shocker, we're doing AI. No, we're finally like kind of getting okay at it. And that's that like baby step feeling I have all the time. I'm like, okay, we finally have bricks we can use. We're getting there.
Well, I was interested in how we're we're combining the AI or the machine learning with the automation. I thought that was the other interesting thing coming out of Think. And the thing I was most excited about was Watson Orchestrator. And for those who didn't see it, there was a video demo that they used, and they had Watson Orchestrator integrated as a Slack bot, and there was some sort of manager. She was asking questions about, hey, what kind of products do we have? How much is this customer buying in the past? She was trying to figure out how to offer a new deal. She wanted to make sure it made sense from a perspective that the customer would buy it, but also she wanted to give them the best possible discount. She wanted to know what she needed approvals for. She went beyond it, and so in the old world, she would have had to go between like 2 or 3 different systems, and as silly that it is, but tabbing out of one thing into the other and back and forth, and you've got a chance to get lost. Instead, she was able to do all this in a Slack. And at the end, sent out the quote, got the automatic approval, and it was, the right price, right everything. And it was, very nicely integrated, all natural language interface. I thought, boy, wouldn't that be nice as I sit here doing something in Excel, then going over to this other thing, and then going to like an email, right? So I was excited to see that you have to have the data, like you said, you have to have the processes enabled, you have to have them exposed, so that they can be automated. And then, hey, we'll put a nice interface on top of it with, the natural language processing, and that's going to be pretty cool. I'm interested to see what else they expand to.
Yeah, like so many things about that. I think that this is when AI starts to freak people out, because once you put that layer of natural language interface on top of it, suddenly it's magic. The computer is talking to you. It knows things about you, and then you start to forget like all the work and the intricacies that go into like just delivering that Slack message to you that are not magic at all.
Yeah.
At all, right? But that Slack integration itself is taking years of development with our teams. And so it's super exciting to like finally see a really like real world meaty instance of like, I can collaborate with Watson. I don't have to, it's not a question search engine anymore. It's like a partner, or it's starting to feel that way.
And I think back to, when I first got my smartphone, like I used the voice thing to set reminders because it's so easy. It's so easy. And set the reminder for this thing at this time. And all of a sudden, now I stopped forgetting things because it took 2 seconds to load it into the phone, right? And that was great to, as an individual, but like you said, to collaborate with others. Let's see, am I going to set a calendar reminder for the two of us? I'm going to send a Slack bot. What am I going to do so that we can work together? And by the way, it's probably specific across all sorts of different tools. So it was really cool to see, hey, we're going to be able to do this in one spot.
And that is kind of like the core of, I think, what's such a big deal about Orchestrate. Like we've been building individual products that all address different needs in terms of like connecting data, connecting computers, processing stuff. But this is something that's like across all of those things together. What do I pull all these different points of data from to give you an answer? Same thing with Watson AI Ops. Like there's finally like a vision for like a single place to monitor not just AI, but like everything in your system, everything going on. How do you keep that? And it takes AI to make that AI stuff work, which is kind of like the catch-22 of it all.
Pretty cool.
Very cool. There's a couple other things that were announced at Think that I thought were really interesting. So like Orchestrate, AI Ops, great examples, and even Auto SQL, like another central location, but this one is about improving speed of connecting data. But those are all, I think, in my world, like they feel like the natural interface portion. But we're also like, IBM is a research company in a big way, like kind of like another Bell Labs, really. We've got over 300 research labs around the world, and they're always, making new crazy things. So 2 big things came out of IBM Research during this conference. One was the I don't know if I'm saying it right, 2 nanometer, big little tech chip. So tell us, do you know a whole lot about that? I've been able like digging into it online.
Yeah, so I'm not a hardware, but I'll give it a shot. So the idea is that I believe it's the chips that are smaller, and basically the more more transistors you can pack on a single chip, the more you can do. Right, the computing is a function of what's on there, right? And what's always been challenging is how do you keep it from overheating, right? Because you can put more stuff on it. But they've cracked a significant barrier at the 2 nanometers, and essentially you're able to pack more in there, make it faster, and or smaller, right? So you've got those trade-offs available to you. I think what that means to us is just little Tim Taylor here, more power.
Yeah, but that's exciting though, because it wasn't that long ago that we thought we had like hit the barrier for like how fast we could get a computer to be, like without like just like adding on many bits and pieces. Like we had reached the threshold using the materials that we have, and that's all the faster computers are going to get. And we're proving that wrong, which is crazy to me.
Absolutely.
Absolutely. And then taking it like even further, the other big announcement on the hardware side, well, it's like hardware software, was the Quantum announcement that they've now got like a containerized software solution hosted up in the cloud so anybody could use it. That's about improving software and processor performance of IBM Q, which is IBM's quantum systems. So something, what did they say? 120 times faster. That's crazy. That's good, right?
Yes.
And so like, what does that mean for AI? Like we need the faster computers. Okay, so now if we have these faster computers, what does that mean that we can do?
Yeah, so there's always problems that we left sort of, that we didn't do because you couldn't do it, right? You didn't have the processing power. Neural nets, it's not like we didn't know how to do them before. We had the theory. We didn't have the hardware, right? So maybe now it's a bigger neural net, or maybe it's something that we haven't even conceived of, that's able to solve even bigger data problems.
Yeah. It's interesting, like how science works that way. We have a hypothesis. We can know things before we actually can prove them out.
Yeah.
And now we're kind of getting to that point. I think with AI, like even like with the teams that I work with every day, like how much data can we process? If we can process data now, what answers could we tell them? Well, now things are going to move that much faster. Like, gosh, we could pull in huge data sets. We could pull in data sets from all over the world, and we could get that answer to our customers in like a time frame that doesn't feel like a dysfunction.
Mm-hmm.
Which is kind of the thing, which gets back to the natural. They're also like intertwined.
Yeah.
I can't give you an answer like 2 hours later and have you be like, oh, thanks. No, it has to be like that. Okay, so other things from Think. Today we talked about Orchestrate. Maximo Mobile. Are you familiar with this one?
This one I don't know.
Okay, so Maximo is a tool that helps companies manage all of their different assets, like in buildings, at sites. So like their main use case here is like someone who might like go out to like an oil field rig situation and have to like look at meters and numbers and figure out like, is it doing the right things, or how do I fix it, or what's wrong with it? So Maximo Mobile is a way to like do all of that without needing internet connectivity, and while collaborating with their Watson AI. They're definitely going to be using neural networks, natural language, machine learning to pull all of the data that they have about like a specific part number or a specific location and everything that's happened, so that you could just like take a photo of the rig that you're examining, like one of its little instruments, and then Watson could tell you, you need to do this and this, or this part needs to be reordered, like whatever it is. So again, like faster data, because we're bringing it all down into like edge and data fabric networks, and then we're also using natural language on top of that to make it so like anybody could just like use their phone to get these great answers for how to monitor their stuff. And that's a huge step forward for Maximo, which has been building like multiple different products to do individual different things that are now seemingly coming together.
The scale of the information and the problems that you could solve with that just gives me nightmares thinking about how you would track it manually, right? Well, hey, what parts in my enterprise? Oh goodness, don't ask me. and then things that are connected to each part, which ones are going out of service, or which ones need the maintenance soon. I mean, there's an untold number of things that you can do in that space.
Yeah, it's overwhelming. And if you're new on the job, or if, you know, the master leader who was great at it just left, like, where does that data go and how do you get it? And it just like, it solves so many human, not so great at this thing problems. which is exciting. Along those lines, they also announced this project Codenet, which I had not heard before. Large-scale open source database comprised of 14 million code samples, 500 million lines of code, 55 programming languages, and it can like auto-translate it into different code languages for you. That's like a modernization thing, but you tell me.
Well, it's very interesting. So
here we go.
So I'm in a project where there's mix match of some of it's Java, some of it's Python, and hey, wouldn't it be great if it was all one, then one team could manage it. And so you think about, well, how would I port that code, right? Port half of it to the other language. And you say, oh, okay, I could do that. And then you start on the first class and you're like, all right, that was hard, but I could do it. And by the second or third, you're like, I'm never doing this again. Can I have some help? Right?
Really?
Can I start to see the patterns? Because each of the programming languages, they have their own pattern, their own way of doing things. Right. So if you said, hey, I've got some pseudocode, go write it in whatever language. If you wrote it in 10 languages, it would probably look completely different, 10 different ways. I actually have a book for my kids where it was A to Z in programming languages. I think they did Hello World 26 times, and you think, well, how many variations could there be? And there's 26. There's more. Right. So the ability to quickly find, hey, how do I do this Java thing in this Python or this other language? That would be a really, really interesting thing for programmers. The other way I think of it is if you go to Stack Overflow and you say, hey, how do I do blah, blah, blah? Then you have to type in Java, right?
Mm-hmm.
Which is going to slow you down. What if you found somebody did it in Python and you need it in Java? How do you get to there? You either need to understand both languages or you need to make another query and hope that somebody else solved your problem again. Right. So I think of it as just expanding the number of questions you can ask while reducing the number of data points you need.
Is that like kind of like the path?
Is that what?
We have massive feedback. Is that leading down the path of the computer being able to write code for us? Like if it's translating, couldn't it?
Well, this is the problem we've been going after for years in the industry. What if you could automatically convert a spec into code, right? And the challenge is always that your spec isn't unambiguous until you've got it as code, right? So let's say you said to the computer, hey, write me a code that does X, Y, and Z, and it could do it, right? Maybe for a simple one, it's fine, but the farther up you go, the more powerful, the more things you're asking for, the more gaps there are going to be when you describe it, and the way it implements it. So maybe it can generate the outer shell of it for you. Maybe it generates the 50% or the 70% or maybe 90%, but there's still going to be holes, right? Where it was just hard for you to be precise enough, and maybe you didn't even know you were being imprecise until you saw what came out of it.
Like, you think, I hadn't thought of it that way, but like code is spec. Yeah. Code is interesting. Yeah. We have that problem a lot, especially as, well, even in like the design teams, right? Like we have this Carbon language that everyone's supposed to use. It's built in one thing 10 years ago. Almost all the teams have now transitioned over, but like the effort of transitioning from like one language to another just to build the interface is so much technical debt. It's crazy. So I'm excited about that one. It just means they can work with me more on my stuff, hopefully. Okay, so overall, I kind of wanted to maybe just get your feelings about where are we headed with all this at IBM? And especially like for you from an external, like working with customers perspective, where do you see our needs? Or now we're getting there.
Oh, that's a great question. You saved an easy one for Friday afternoon, right?
Yeah.
No, the automation. I think that's that. I mean, the AI is fun, right? But the way it enables automation, I think that's where it's going, because all of it's for, faster, better, stronger, cheaper, or done in the way that you want, right? I mean, even if I think just about chatbots, it's not like we're answering questions that have never been answered before, but we're bringing it to the user, right? Beforehand, you had to navigate my website in exactly the way I wanted you to, or you wouldn't find it, right? And now you can ask the question the way you want to, right? And drive it that way. But maybe you don't want to chat, maybe you want to call on the phone, right? So there's so many different angles, just from I guess a channel's point of view. How can we make all of them work? And going back to the example of the one I started in the beginning, they wanted the chatbot to help them get on the network. Well, nobody had ever written down how to get on the network before, right? So I think we'll be spending a lot of time helping people, get to even just digitize, right?
Yeah.
Or to be more structured, more organized about how they're doing their processes, and then the fun part, exposing it out through an AI.
So I have a chance to ask you as like a subject matter expert, how does Cloud Pak for Data play a role in that? Like, we have these tools now for like, here's where you can put all your different, data sources, like no matter what kinds of clouds they live on, you can pull it all into like one library, and then you can like clean it all up, and you can, mask off parts that you want to keep private. Like, is all of that stuff, does that seem to be going in the right direction to you, like making it more accessible to everyone, or is that?
Yeah, absolutely. I mean, you think about before you had that kind of technology, it's not like people weren't doing it, but they were doing it all their own way, right? And you didn't have any visibility into how they were doing it. And if you wanted to get onto some tool, you had to bring all your data into that tool, right? So just it sounds simple, like the data catalog, but that's really something that you don't have to bring the data in, but you can reference it and leave it where it is, right? That's pretty cool. For some of them, I've even seen you can push the compute out to where it is too. So it's much, it's how do you say it? It's much friendlier to work with. It's not enforcing you that you've got to do everything our way or the highway, right? But it lets you go where you want to, and data is just hard to organize, right? So that we've got a scheme where you can organize and you can be explicit about all your different rules, like you talked about the masking. Well, right, that's probably a corporate policy. We're gonna deal with social security numbers this way. Well, wouldn't it be great if I could define that and everyone can reference it, right? Rather than just sending out an email and saying, hey guys, hey gals, you need to do something about social security numbers, and boy, I hope you do it. Right?
Yeah. Now we have feedback again. Hold on. Is that better?
Yeah.
No. Yeah. Oh, okay. There's my voice gone. I have always worried that as we're trying to imagine a new way to connect, actually just to make data scientist tools, like traditional tools, easier for everyone, we will lose the data science audience because once you do things one way for your whole life, you're not going to want to switch over. How does that go? So
I'm not worried about that's the least of my worries, because typically when a company hires a data scientist, the data scientist is all excited. They're like, man, I'm going to come here and slap some machine learning on some stuff, and we're going to go to town. And then they find out, well, the data's crap. Nobody knows where it is. there's nobody's actually interested in getting the data, right? So, and then once you get it, oh, now you have to set up your Python environment, and none of your tools work with each other, right? So they're very excited to apply data skills, and then they spend all their time with things that are not that interesting, the data janitor type of stuff, right? So,
yeah, data janitor is job security these days.
Well, I think I think as the data janitor goes down with the new tools and new methodologies, you'll be able to do all these fun projects that you're interested in, but are so expensive. Like, so if you're a company and you're like, hey, I'm going to do my first AI project, and you find out, the data was garbage, and you spent 95% of your time in prep, and then you didn't really get that exciting of an outcome, you're not really interested in doing your multiple other AI projects, right?
Yeah.
But if we show you that, hey, we've brought down the ugly part, reduce that 95% to maybe the 10%. Well, now I have all these other burning questions I'd like to do, right? It's not like they're short on things they're interested in analyzing. That's my perspective. Just that they know how expensive it is to do anything, right?
Yeah.
That was sort of the barrier before. So I think it'll be one of those, even though it's easier for the data scientists, I think they'll find out there's more demand, there's more things to do. So I don't think they're going to be sorry to see the data janitor work go either.
Right? No, not from the ones I talked to. Like, yeah, okay, that's not what I got into this for. Is organizing text. So as far as like coming up with ways like to use the data, what kind of questions, like how should we analyze it? Should we analyze it? That's what we've been working so hard on with Watson Studio. Like once you get all that stuff cleaned up, once we're through that infancy phase that we all know we're like really still in, and why Watson Studio is like a smaller product offering than cloud, because everybody's getting your cloud pack for data, everybody's getting their data organized. And as that happens, then you'll see Studio come up more and more. We're trying really hard to like show people what Watson can do. And that's kind of like what the Watson Moments program is about. But do you think people know what Watson can do? Like these data scientists that have, once they get their data cleaned up, they're like, do they even think about Watson as a tool to use, or is it just like, I want to build it from scratch on my own, and that's the direction I'm headed?
Interesting question. I think the data scientists, they're knowing enough about the tools that they're using, and I think they'd be glad to have tools that worked well for them, and not just worked well for them, but had a chance of working a second time somewhere else. I've seen so many data science proof of concepts that, you see all the code, you download it, and it doesn't work. Like, oh yeah, well this dependency changed, and now nothing works anymore.
Yeah.
Right? So the reproducibility is pretty interesting. But I think for the non-data scientists, I think they're way less interested in, hey, is it Watson or not? But that's where Watson Moments is really interesting, because it gives them a nice reminder of, oh, hey, this is something the AI did for you in kind of an explainable way.
Yeah. Which was the goal. Like, here's a really visible, tangible way that you can understand what Watson does, because it's doing something that you're working on, and here we're going to show you what it's doing, and like here's the value that it adds, and here's why it's doing it, and like some nice, very accessible, touchable, real experiences, right? Even though we're not, I haven't even introduced this. We're calling this Watson Moments internally. Externally, this is just Watson across the board, and almost like a marketing campaign, but in our products. But I will say, from like the design or product team side, it's still really challenging for us to always know what insights we could provide with that data, and to be thinking along those lines.
Do you have a favorite Watson moment, or are they all like your kids and you love them all equally?
You're gonna get me in trouble.
Then I'll pick one because
My favorites are the ones that have launched so far. I'm very happy with those teams, probably because it's a lot of work. It really is.
I remember when the Weather Channel app, when it first told me, it was something totally surprising. It was, I think it was almost like, hey, the weather has dipped and therefore there's a higher chance for the flu.
Mm-hmm.
Oh my gosh, how did you know that? And they had the little pop up, and it was a Watson moment, right? And you could click through and read how they determined that. And first of all, it was just such a cool thing, and it was a nice reminder that, hey, aside from it telling me it's going to be 82 and sunny today, that's not all they're doing with this data, right? That they're really looking at it, and it just shows me there's more going on. You can get kind of complacent looking at the same thing over and over. That was pretty cool.
Yeah, and like that's what makes it fun, and like what we hope like every Watson moment does. Like it has this like magical, like, oh my god, I didn't know that. Like literally something. What can you like equate it to? I don't know. Like favorite technology experience. You're like, oh, magic.
Yeah.
That is really challenging to come up with for every product. And there's also that threshold of like what's amazing for one type of user, not so amazing for another type of user.
So the cynical users are sort of the the bane of your existence here. Huh?
No, it's kind of more like that doesn't seem that amazing. And then, to like an outsider, but to the person that has to do that work every day, they're like, oh, thank God.
Yeah.
They're like, oh, automating that doesn't seem like a big deal. Like we should just do that. But you don't realize, like in the day-to-day lives of people who are like sitting behind a desk, tolling through this work, like it's a big deal. So there's always like that threshold gauge. But pushing things to be magical, I think, is why I get excited when we see things like those three areas, like computers are getting faster, data's getting better, and interfaces are getting more and more natural. Like that, like it takes those three things for that magic to happen. But it's still not a natural, I think, way of thinking for designers to ask those questions. And that's why I hope this year and maybe it's actually more next year, but we start to like change the way we do design thinking as more, even though we say it and we do it all the time, but like pulling data science and design together closer to a shared brain anyway.
Yeah. Look, I mean, we come back to this all the time, that shared brain, or the different perspectives in the room. It amazes me how long it takes to get everyone on the same page, and that's no matter what you're talking about. And even people who sort of want the same thing, like it's so hard, right?
Yeah, it really communication, which is the whole point of all of this. Hopefully, like, can we understand the world better with this technology? I'm going to dive off onto a whole different tangent unless you want to pause and talk more in depth about the Think stuff and the products and things.
No, I can't wait to hear the tangent now. These are always so exciting.
Okay, glasses off for this one. So let's talk about really the coolest stuff that's happening right now, which is the government releasing new information about UFOs.
Oh, wow. All right.
Are you keeping up with it?
Let's do it.
Okay. So last month they released like this whole big binder of reports that they've been working on called the UAP project, the Unidentified Aerial Phenomenon, and they've confirmed that there are UFOs, although they don't know what their origins are. Like, are they alien? Are they super terrestrial? Are they from another? Actually, they're talking about other countries.
Right.
I'm the one that's at the super terrestrial time machine shit. But I think it's really fascinating because it talks about how UFO crashes are kind of like donations of technology. and how this phenomenon has been tied to the development of technology all the way back to the 50s when we started really unpeeling the AI onion. And it makes me wonder, I'm like, are we furthering the technology that some other source has given us and they're just kind of guiding us down the path? What do you think, Andrew?
I'm skeptical what we'll find, in the sense that, you know, lots of people, they see something and it turns out to be a weather balloon or a you know, just a flash in the sky, or a lensing or something. There was a book I read, and I looked up the title here. It was called "How I Killed Pluto and Why It Had It Coming" by Michael Brown. So this, and this is a great book. And basically the technique he used, so he was an astronomer who was looking for extrasolar planets, or I guess within our solar system, whatever you call them. And the technique he used was the same technique they used to find Pluto. They take pictures of the night sky 2 nights in a row. You look at the picture A, picture B, you see if anything's different. And if something is different in them, it may be a planet. Right? Maybe something you haven't seen before. Right? So he tells a story that he'd spent, I don't know, like 2 years taking pictures of the sky, because every night they would do like one little bit, right? Like 0.1 degrees of the sky. And he had thousands of images, and he wrote a little computer program to look for differences. And he found like 10,000 differences over the first year. And then he marked them all down. Like, then, well, he had to write a software program to help him, you know, translate between the images. And the first time he did it, all 10,000 of them turned out to be like, there's a flash on the telescope lens, or it was nothing, right? On 10,000 differences, poor guy didn't find anything. Now, later on, he got better technique, and, you know, his hit rate was like 1 in 10,000 or something, but he discovered 3 or 4, you know, planetoids, dwarf planets. Said no, Maki, I forget the others, but they are, you know, this guy found that group. So where I was going with the whole very long story was, you know, he had this giant treasure trove of stuff that he thought, hey, you know, I got it. And then he'd work really hard. Like, it was a big software project to look at the images and tear it down. So now that we have the data, we can do that same kind of analysis project and find out, hey, of these 10, of those, however many are in there, you know, where are the really interesting ones?
Isn't that exciting? Yes.
Cool.
I was listening to a show recently, and there are like several grassroots teams that have been using machine learning to do similar things, but more locally. I'm sure someone is doing that with space objects, but they're doing it with like unidentified aerial phenomenon, just by like making like, here's a Raspberry Pi powered device, and we put together this little kit, and you can put it on your roof, and it's a fisheye lens, and you're constantly taking photos, things happening in the air, and then you go and you look, and you're like, that's a bird, that's a plane, that's Superman. And they're building this database of identifying objects and objects that we can't identify.
Yep.
With AI, maybe the AI that the aliens gave us.
Well, my fingers are crossed, if only for you.
Thank you. It is interesting, though, how much technology really has an impact on like our culture, our religion, our beliefs, and that those two go hand in hand. And like, you can't really, like, what seems like magic to one generation is only the norm to the next. And I feel like we're crossing a threshold recently, and quantum is going to be another one where we're like, ooh, that shit's fast.
Yeah.
See much bigger pictures of the universe. When we can see much bigger pictures of the universe, what happens to us? I don't know,
but we're going to have to sort it all out.
we are. Yeah. But, you know, that's why it's, you know, I love it. It's all tied together. We should have philosophers and religious people and archaeologists all like talking about this stuff. That's my next goal. Get some archaeologists on my team.
I love it. We need more of that.
We do. So have we beat this horse to death with the Think thing? Is there more stuff we should talk about?
I think we've done it. It was a great show. I'm ready to do the plugs.
Okay, take it away.
All right, so people, thanks for joining us. You can find more about the show, AI Zen with Andrew and Jen. You can find us on Twitter. You can find us on LinkedIn. Jen, where can they find you?
LinkedIn, Medium. I write a lot on Medium. Yeah, that's it.
And they'll find you. Look up Jennifer Aue, AUE.
Yeah.
For me, they can find me, Andrew R. Freed, on Twitter and LinkedIn. And my book, I would love if you checked out my book, Creating Virtual Assistants, on Manning.com, and code Freed PC, as in Freed Podcast. You get a little discount on that. So love if you checked out any of those. Leave us a comment, leave us a review. We'd love to hear what you thought of this. Thanks everyone for joining us.
Bye.
Bye.